Welcome, everybody, to another webinar from Aventec. This time we'll be talking about Abaqus 2021 updates. In this presentation, we'll be talking about the latest updates in the Abaqus product, including CE, the GUI, as well as the solver. Today's presentation is going to be segmented into three main sections. I'll be introducing the updates as they relate to the Abaqus CE, what's new in terms of the GUI and all the different functionalities at the graphic interface level. Then followed by an introduction to the linear functionalities as the updated in Abaqus 2021, and then followed by the last section where I'll be talking about the nonlinear functionalities in Abaqus 2021. So, what's new in Abaqus CAE 2021? There was a whole lot of effort in order to upgrade the user experience at the GUI level, but the GUI has not changed radically, so it's exactly the same as the previous releases. But there was a new implementation of the 3D experience, which makes the connectivity between the standalone version of Abaqus CAE and the platform very seamless through the 3D experience connection, also called Power By. So the user can launch CAE from the 3D experience using the connector from Abaqus, either on premise or on cloud. This comes very handy when the users are trying to investigate burst computing or cloud computing on the platform without the need to change new GUI and dealing with all the new software functionalities as represented by the 3D experience. So it makes life quite very easy in that sense. So all the user has to do is to develop or build the input file using Abaqus and then import it to the 3D experience platform, and in order to run it. Also the great part or the great component about this is also like the data management component, providing very light weight visualization models for either for support or for management. It makes things more seamless, more straightforward, and more easy to manipulate without having the user to get into a steep learning curve by learning a new software again. So still talking about the 3D experience connectivity between Abaqus and between Abaqus CE and the 3D experience platform. The files could be saved on the 3D experience, and different types of data could be generated, either the ODB file, CAE input data, etc., and everything could be visualized either on a full-blown version or a light version, depending on the user's wish. And switching to another topic. Previously, the gap conductivity or the at the thermal contact level, the gap conductance, radiation, or convection were supported at the interaction level by defining the interaction properties. Now, this keyword is supported at the GUI level during the material definition. So users can define either gap conductance, radiation, or convection, and subsequently define the material parameters as they relate to each one of these material parameters. As far as the composites concerned, for the GUI part, there was a huge effort for developing the composite technology either at the solver level or at the GUI level. Now the Edit composite layup definition supports analytical field for ply thickness, which improved the performance and the definition of the composite layup significantly. The material column in the material section or in the section manager could support multiple materials right now, especially we have like a section that it's composed of 2, 3, or more types of materials, in this case composites. So we could define multiple materials for the exact same section, which is fairly straightforward. That will have a big impact on the usability of this option. In terms of the contact property assignments, now we could assign properties by material. This follows an Abaqus solver development back in 2020. So now the contact assignment can use the either surfaces, materials, or a combination of the two. Materials for the exact same section with the support for additional types of surface property assignments for Abaqus standard, and for Abaqus Explicit, same thing, enhancing the surface property assignment supports by providing cross trigger assignments and the surface friction assignments as part of the GUI enhancement. When it comes to the small sliding, has been added also for the general contact for Abaqus standard. And for the submodeling, now we could support intersection only for the keyword star submodel, or from the GUI when we edit the boundary conditions, we could assign an intersection only in direct Abaqus to ignore any driven nodes outside of the region of the global model when we're dealing with submodeling. I would like to talk a little bit about the ODB Reducer Builder plugin. This enhancement is the integration of a plugin that comes to us from the field support. So you may have heard of the ODB Reducer tool, which is a plugin that existed for God knows how many years, or the ODB extractor / builder tool. So this is a new implementation with an extensive set of features. So we decided that this plugin is very important, and it's really widely applicable to customers from a variety of industry or sectors or fields. And now it's included in Abaqus out of the box, so the user don't need to download the plugin, find it, and install it. So it's out of the box, it's available. So a lot of users have been inquiring about it, and it makes life quite easier, especially in the case when we have like a huge ODB files. I'm talking about gigabytes of data. Users need to extract just like a simple amount of data to share either with their support engineers or their management. So not the whole full-blown ODB file is needed in this case. So just some subsets that are needed. In this case, the ODB Reducer builder could make this possible. The shear flow visualization has been implemented back in 2020X or Abaqus 2020, but the arrow appearance was not that good, so it did not honor the settings in symbol plot options. So now that capability has been fixed and enhanced as well. Rendering the composite solid prism elements. This was more of like a bug fix that has been addressed in the previous releases, but which has been fixed, and now it's available as part of the Abaqus 2021 GUI. The SolidWorks Associative interface now export multi-body parts as separate parts, and it's more of like similarly when importing like a step file directly from Abaqus, where you could export or import each body as a separate part, retain or amalgamate the whole assembly into one singular part. So those improvements are available as part of the SolidWorks Associative interface. Other improvements, we call them here miscellaneous improvements, are related to the direct CATIA v5 part import, which is now available on Linux. This capability has been available forever in Windows, but it's just been incorporated in Abaqus 2021 under the Linux environment. The next step, or the next section, I'll be talking about the linear functionalities or the linear improvement at the solver level for Abaqus 2021. So first thing first, I'm going to be talking about the linear analysis, current state, and recent enhancement. So when we talk about linear analysis, the first thing that comes into our head is the linear static analysis from the general step, but that's not totally true, because that's depends on the way the model is being set up. Not necessarily purely linear, as opposed to the linear perturbation steps where the solver imposed the linearity condition on all the models built using that type of procedure, which could include the linear elastic static, eigenvalue extraction, steady state, transient, random, response analysis, response spectrum, etc. So the modern finite element technology includes a tremendous amount of element libraries, advanced models, sophisticated constraint capabilities, as well as a state-of-the-art matrix input and substructure modeling abstraction. Also, there's a very rich material level and system level damping capabilities depending on dynamic analysis or the dynamic physics that we're trying to replicate through the simulation. And of course, we have various output options that are specific to linear analysis. Features such as acoustic contribution factors, energy flow, and RMS misses stresses. And of course, like to mention the high performance scalability, either for the direct or the model solvers using multiple CPUs or GPU devices. So one of the major improvement to the Abaqus 2021 was the result output performance and scaling. This functionality is been available for 2021 FD03 release. So just a quick touch base on the linear analysis state of the art. So the performance on the scaling of the linear analysis with multiple load cases was improved significantly in the last couple of versions, mainly in Abaqus 2028, 18, and 2019. We removed the limitation due to the number of the load cases for large models for the MPC recovery. We improved the performance of writing the solution into the internal Abaqus database, as well as improved the performance of the right-hand side assembly algorithm of the sparse right-hand side vectors, among other improvements. The performance of the output analysis phase has become a bottleneck in large-scale multiple load case analysis, especially when we're dealing with fatigue and durability workflow that require the output stress for the whole structure for many static load cases or certain number of eigenvectors. The performance of these analysis phase can be a very painful blocking condition, and for certain automotive workflows, they include the strain energy output for hundreds of eigenvectors and stress output for the full model for many load cases in the model frequency response. So the performance for the element output and linear analysis procedure is substantially improved. Here we illustrate this in a small example of a square plate with 4 million shell elements with 4 nodes S4 and 24 million degrees of freedom. The stress output for the model at the integration point, top and the bottom in the section of the section. And here we could see like a nice comparison between Abaqus 2020 and Abaqus 2020 hotfix 3 and Abaqus 2020 hotfix 4. And of course, the same capabilities has been incorporated into Abaqus 2021 as well. So there is a reduction factor in terms of the time by almost a factor of 2 between the total analysis to the output analysis phase. One of the nice improvement that I personally like is to remove the node limit for the execution in one singular compute node. This is kind of like a very common misunderstanding of the size of the model versus the capability of the solver itself to run it. So now there is also an improvement in that sense where even larger models than 16 million nodes, dozens of millions of degrees of freedom can be run on one singular node. The only downside here is probably you will get the response within a month instead of within hours if you use multiple CPUs. Matrix modeling abstraction. So this is going to bring us a little bit deeper into the finite element model or in terms of the abstraction of the technique. So the a simple finite element model can be summarized in terms of a set of matrices that would represent the stiffness, the mass, the damping, and the loads / boundary conditions in the model. Using these matrices, one can exchange model data between other users, vendors, supports, or even software packages without exchanging the mesh or the material data. So the matrix generation procedure is a linear perturbation step that accounts for all the boundary conditions, loads, material response in the model. And this capability allows the generation of the stiffness, the mass, the damping, and the viscous damping or the structural damping, and the load matrices for the full model or part of the model depending on the need. And then the keyword here is star matrix generate, comma, space, stiffness, mass, viscous damping, structural damping, or load, depending on the case. So the generated matrices are stored on the SIM file, which is a high-performance database available on the Abaqus run directory. And the matrix generation analysis, the analysts can also use the to output the stiffness, the mass, the damping, or the load matrices into a text file. And we can define the format accordingly. So the Abaqus standard provides the capability to also input the stiffness or mass or viscous or structural damping matrices. During an analysis, these matrices are added to the corresponding global finite element matrices to complete the assembly of the entire model. The matrices can be imported, therefore, from the text file or from the generated binary sim file. As I explained in the previous slide, the same exporting technique. So here we could import it using the keyword star matrix input name equals name of the matrix, and then input a file, either a text or a sim file, and then define the nature of that matrix. Is it a stiffness matrix, mass, damping, or load matrix? Also, the solver allows to input both symmetric and unsymmetric instances of the same matrix. We just need to define that as part of the optional inputs or parameters of the keyword star matrix input. We have to define the type. Is it symmetric or unsymmetric? And the matrix subassembly defined by the stiffness, mass, or damping matrices can be associated with different sets of nodes in the specific model, translated, rotated, reflected, and used multiple times like a substructure. For example, so different types of manipulations of specific matrix or subset of a matrix could be used, including translation, rotation, reflection, or specifying the Euler angles. The interface node of a matrix subassembly, this functionality has been first available in the Abaqus 2021 FD03 release. Now we are on the Abaqus 2021 hotfix 5 or FD05. So the new matrix interface nodes feature improves the usability of attaching a matrix subassembly to define an element model using a subset of keywords, including matrix generate or matrix assemble. The next couple of slides, I'm going to be talking about the Nastran or the ANSYS translator, the translators. These functionalities have been available. The translators have been available for a while now, but their capabilities have been improved significantly in the last couple of releases. We're talking about new translation option for Shear elements for Nastran bulk file. Certain improvements are related to the performance, which is reflected in the translation time, that it's significantly reduced for large models containing millions of composite shell elements. Thermal expansion translation for RB2 elements, negative structural damping translations, as well as DMIC to SIM translation improvements. And of course, we're talking about the Abaqus-Nastran interoperability for structures. So for a Nastran substructure in a bulk file, text file, or an output to binary file can be automatically translated to by Abaqus using a from Nastran translator as depicted here. The fromAnsys translator enhancement are related to the size of the models that could be translated, as well as the efficiency of the translated model as well. So the contact is not yet fully supported by the size of models that could be imported from ANSYS model into Abaqus could have increased significantly. And the example that it's depicted here, we're talking about an ANSYS model that has 2.8 million elements, 5.7 million nodes, and 18.6 million degrees of freedom, with millions, 22.2 million lines as part of the ANSYS input file definition, with thousands of contact pairs. Abaqus 2022 translate 2020. Pardon, simply failed, but Abaqus 2021 translation succeeded, and the Abaqus input file was reduced to 9.7 million lines instead of 22.2 million lines for the ANSYS input file, and the work still continues. The next section, we're going to be talking about the nonlinear functionalities in Abaqus 2021. We're going to start by introducing what's new at the element technology. We could remark that there's a huge effort to improve the functionalities related to the composites technology. So here I'm going to be talking about the composite solid enhancements, then followed by beam general section enhancements, and then the mesh composite cross section. Composite solids enhancements. So now all the three-dimensional stress displacement prism elements are now supported with composite solid section in Abaqus standard. The composite prism elements could be included using the keyword star solid section, comma space composites, comma space stack direction equals 3. Ironically enough, only the default stack direction equals 3 is allowed for the composite prism, so it's not really optional, but it has to be there. Simple example here is illustrated using the composite elements, composite section with elements C3D6 and C3D8 R reduced integration. The layer thickness distribution for composite elements could be used to specify spatially the varying thickness on a layer. So the layer thickness could be adjusted such that the sum corresponds to the total element length in the stack direction. The supported elements for this option are brick elements, continuum solid shell elements, or prism elements. User-defined orientation with continuum solid shell elements will not be projected onto the element mid-surface if the new environment variable is used. And this was stated starting with the Abaqus 2020 FD02 or hotfix 2. When a user-defined orientation is used with continuum solid shell elements, the orientation is projected onto the element mid-surface in the initial configuration such that the local material three-direction spatial coordinate is normal to the element mid-surface. In geometrically nonlinear analysis, the local direction rotates with the average material rotation at each material point. The same as for other solid elements pretty much. If the element undergoes significant transverse shear deformation, the local three-coordinate or three-direction will no longer remain normal to the element mid-surface. Beam general section enhancement. So we introduce a new material parameter for the beam general section definition. So the keyword was star beam general section, and now we could add material definition at the section level or at the material level as usual. The new material parameter beam general section is supported for both Abaqus standard and Abaqus explicit. If both start elastic and start expansion are temperature and or other field variable dependent. The number of dependencies specified must be the same, and the values of the independent variables in the tabular definition must be also the same. If both the density parameter and star density are specified, mass density from the material definition is ignored, and the parameter from the section definition will take precedent. And if star damping is used for both star beam general section and star material, the damping from the material definition is automatically ignored. And this functionality has been available since Abaqus 2021 FD03. We also know the introduction of two new open thin-walled cross-section. One is called channel on the left, and the other one is on the hat. Each one of these new cross-section types has specific geometrical input data that are listed in the figure here. The new channel and hat cross-section are both supported in Abaqus Standard and Abaqus Explicit, and they are supported for all the beam element types, 2D and 3D beams, including either the Euler-Bernoulli or Timoshenko beams, warping beams, hybrid formulation beams, and tapered beams. And they're only available with star beam general selection, with the pre-integrated beams, and these are available starting Abaqus 2021 FD03. Now I'm going to be talking a little bit about the meshed composite section or cross-section. So the mesh composite section are related to the predefined library beam sections that are not suitable to model the complex geometry and the multi-material makeup of a common cross-section of beams, like the structure of practical interest depicted here in this example. So in the case of a meshed cross-section that could be used to model a beam across the section, a beam cross-section, or to generate the beam cross-section properties and recovery matrices, appropriate for subsequent use in a beam analysis using the star beam, the keyword star beam section generate functionality. The new family of three-dimensional free degree of freedom warping elements have been introduced to model the mesh composite beam cross-section. The elements are depicted here. These elements capture the effect of free unconstrained in-plane and out-of-plane warping on the stiffness properties of a composite beam element with this cross-section. Here in this section, I'm gonna be talking about the material enhancements. Some material, a lot of enhancements for the Abaqus 2021 material are related to the damage and damage for composite materials. So the introduction of LaRCos 05 damage criteria is going to be depicted here. So the LaRCos 05 damage initiation criteria for polymer matrix fiber reinforced composites was previously available from the built-in user subroutine. Now it's available as a keyword-based functionality using the keyword star damage initiation criterion equals LaRCos 05, and 4 different damage mechanisms and associated outputs are available from matrix cracking to fibers, either kinking, splitting, or tension of the fibers. And it's supported with three-dimensional solid plane stress, shell, solid shell, and membrane elements. And it's also available with enriched elements using the extended finite element approach. The introduction also of Hosford-Coulomb or HC damage initiation criterion was incorporated as part of the Abaqus 2021 enhancements. The criterion is based on the work of Roth and Moore, and it's a special case of the ductile criteria, and with the equivalent plastic strain at the onset of the damage. Plasticity strain assumed to have the form depicted here in this equation. The keyword to include the HC damage initiation criteria is simply star damage initiation space criterion equals HC by defining certain parameters such as the accumulation power alpha, the ABC, and the initial strain rate, the temperature, and other variables specific to this criteria. The main damage criterion output is HC CRT, which is has values between 0 and 10 for intact material and 1 for fully damaged. And it could be used in combination with existing damage evolution options. And it could be also used in conjunction with Mises, Johnson-Cook, Hill, Drucker-Prager plasticity model. And it can also be specified together with any other initiation criteria. Each initiation criteria is treated independently as part of the Abaqus solver, and this functionality is available for both Abaqus Standard and Abaqus Explicit. We note certain improvements of the virtual crack closure or VCCT accuracy and robustness in Abaqus 2021, especially Abaqus 2021 FD03. Improvements include the damage-based tolerance for fatigue crack growth, improving the handling of unstable crack growth, as well as the algorithm improvement to ensure the self-similar growth. So for the damage-based tolerance for fatigue crack growth, the linear elastic fatigue crack growth analysis or star fatigue now supports specification of a non-zero damage-based tolerance for the least number of cycles to damage and interface elements. So historically, such an analysis required specification of a non-zero cycle increment-based tolerance. If both types of tolerance are specified, the damage-based tolerance takes precedent. A damage-based tolerance usually results in the smoothing of the crack front in a 3D fatigue crack growth analysis with a skewed mesh. Improvement to the algorithm for handling unstable crack growth will be very helpful in order to handle the unstable crack propagation. So it's pretty much very similar to what we discussed before, but in a different user interface and using different types of keywords here. And we note also certain improvements to the algorithm for handling unstable crack growths. With including the keyword star debonding force equals ramp by defining also the fatigue, the fracture criteria, as well as the tolerance and the unstable growth tolerance, and specifying the control types with or without cutback scalings. The ETA or the N option is an optional new data entry to specify the number of cutbacks allowed to avoid the overshoot prior to the activation of the unstable growth tolerance in an increment, and the default value of the N parameter is 0. Similar cases were studied, and the results have been depicted in the last couple of slides. With that, I would say thank you, and this was the Abaqus 2021 updates.